Scientific notation. Student learning objectives. Define a scientific notation. Given a number in a decimal notation, write in scientific notation, and given a number in decimal notation, write in scientific notation. Use scientific notation to multiply or divide large or small numbers. Define scientific notation. A number written in the form a times 10 to the power of n, where a is between 1 and 10. It can equal 1, but it does not equal 10. And n is an integer. Is said to be written in scientific notation. Given a number in decimal notation, write in scientific notation. And given a number in decimal notation, write in scientific notation. Example, write the number in scientific notation. So for this number, currently the decimal is located here. So and there are terminal zeros after it. So to write this in decimal notation, the decimal needs to move between 5 and 0 here. So when we move it, it becomes 5.01235. When we move the decimal, then we have 10 times the exponent here. That exponent is going to be the number of times we moved the decimal to the left. So we count that. So we count 1, 2, 3, 4, 5. So we moved 5 places to the left. So it's going to be positive 5. So we change this number into a scientific notation. Example, another one, change 0.000151 to scientific notation. So currently this writing it. The decimal place is right here. We want it to be between 1 and 5. So we write 1.5. So we move the decimal to the right. So we count the number of places we moved it to the right, and it will be the exponent for the 10, but it's going to be negative because when you move to the right, the exponent will be negative. So 1, 2, 3, 4. So negative 4. 1.5 times 10 to the negative 4. Notice that the number a, we said, is between 1 and 10. And for these two examples, 5.01235 is a number between 1 and 10. 1.5 is also a number between 1 and 10. Example, write the number in decimal notation. So now we're given a number written in scientific notation. To write it in decimal notation, so this exponent is positive, so that means we move this decimal place to the right 5 places. So right now we have 1.5. There are terminal zeros to the right of 5. So we're going to add those zeros there to be able to move the decimal point. So the exponent tells us the number of places we need to move to the right. So we need to move the decimal 5 places. So moving it to the right 5 places, we have 1, 2, 3, 4, 5. The decimal place will be here. And that is, we added 4 zeros. So writing the this scientific notation and as a decimal notation, we have 150,000. So this is the answer. Another example, 2.3 times 10 to the minus 3. So to write this as a decimal notation, the negative exponent tells us that we need to move the decimal point in this number to the left. And the exponent 3, -3, or if we take the absolute value 3, tells us the number of places we need to move to the left. So we need to move how many places we count. We add, there are terminal zeros there. So we add however many terminal zeros we need, and we move the decimal place 1, 2, 3. So the exponent is -3. That means we go to the left 3. So the number is 0.0023 as a decimal, in a decimal notation. Use scientific notation to multiply or divide large or small numbers. Example, multiply or divide. So let's multiply. These are large numbers. We want to multiply. So when we multiply, we write these numbers in, these numbers are written in decimal notation. So we change the numbers into scientific notation. So the first number becomes 3.5 times 10 to the power of, so the decimal, to move it between 3 and 5, currently it's on this right here. We moved it 7 places to the left. So it would be +7. So 3, 6, 7 times. And the decimal place right now, point is here. To move it between 1 and 2, we move the decimal place. How many places? We count 3, 6, 9, 10 places. So 10 to the power of 10. So this here is equal to, we multiply the 3.5 and the 1.2. We can use a calculator, and that value is equal to 4.2 times 10 to the power of 7 times 10 to the power of 10. They have the same base. We just add the exponents. So this product is 4.2 times 10 to the power of 17. Okay, so this is the answer. Example, divide. So this is in decimal notation. We need to first write each number in scientific notation. So for the first number in the numerator, we bring the decimal between 7 and 5. So 7.57 times 10 to the power of, since we are moving it to the right, the exponent is negative. So we count the number of places we moved it to the right. So we count 1, 2, 3, 4, 5, 6 places to the power of -6 over, we want the decimal to be between 1 and 3 when we convert this into a scientific notation. So it becomes 1.3 times 10 to the power of, so moving it 1, 2, 3, 4 places. Since we are moving it to the right, it will be -4 for the exponent of 10. So next, what do we have here? We have 7.57 times 10 to the power of -6 minus -4, using one of the quotient rule. 7.57 over 1.3 times 10 to the power of -6 minus -4. Okay, so this here is equal to 7.57 over 1.3 times 10 to the power of -2. So the exponent is negative, so it needs to go in the denominator. Okay, so let's continue. So this becomes 7.57 0.57 over 1.3 times 10 squared. Okay, so we have 7.57. Let's divide 7.57 divided by using a calculator. Our result is 5.82 over 10 to the power of 2. 10 squared means 100, so 5.82 over 100. So dividing it by 100, we get 0.0582. Remember, when we divide by multiples of 10, we drop the 100 and we move the decimal to the right by the number of zeros we have in the denominator. This we have two zeros, so we move the decimal in the numerator 2 places to the right. So this division here is equal to 0.0582 as in a decimal notation. If we want to leave it as a scientific notation, it becomes 5.82 times 10 to the power of -2.